We are looking at enhancing the number hunt project from the YByte Python curriculum available at www.ybyte.in. In fact, a very interesting idea comes from the fact that, why must our number hunt always run between, let's say, 1 and 100? Why can't we do the same thing on some special numbers? For example, we could pick up numbers that are, let's say, multiples of 2, 3, or let's say any other number, maybe 5, 7, or whatever. We could pick up the list of all prime numbers. We could pick up numbers that have some very special properties. For example, the game where we avoid numbers that have sevens or that are multiples of 7. We could pick up, for example, Fibonacci numbers. In fact, the list goes on and on. So we can make the game so much more interesting by saying, okay, look, I'm going to pick up these numbers from a very special set. Let's see how we can do this in this video. There's really actually three steps that we must do. Number one, we must generate the list of numbers. Now, remember in the class game, we just said, okay, number is between 1 and 100, but now we are going to use some kind of a mechanism to generate a list. Now, typically, this will require either a for loop or a simpler method is list comprehension, which is kind of like similar to for loop. If you understand, you can sort of get the idea. That's what I'm going to look at. So I'll give you some examples of this, as we go. The reason we need this is because, now the entire game is working on top of that list because, that's where the numbers are being chosen from. The next step that we must add to our existing game is that when the player is guessing, remember the computer picks, player guesses. Now we must make sure that the player's response is a valid response. And in this case, it's simply just a matter of checking whether the response that the player is giving, is it a part of the list of numbers that we have. For example, let's say the list of numbers is all even numbers, then the user cannot be guessing an odd number and so on. Also, when the computer guesses, now everything happens from this list of numbers, much like, when we deal with alphabets. So we just have to work with indices, and that's pretty much about it. We just have to be a little bit careful. So let's see each of these a little bit carefully, starting with, say, step number one. So like I said, we need to first generate the list of numbers. Now, remember, previously we just looked 1 to 100, but let's say we want to get the first 100 even numbers. Then, the way we would do it is to say, okay, kind of like, think about it, that we just need to run a for loop going from, let's say, 1, 2, 3, 4, 5, 6 until 100 and multiplying each of those by, say, 2 times. Now we could do it in a for loop appending to a list, but in Python, it turns out there's something called list comprehension, which is what I'm showing you here. I can just write a very concise statement. Look, I want X to go in range 1 to 101. Range function works by starting here, going in steps of, without a step being given, going in steps of 1 to one number before this. So basically it's going 1, 2, 3, 4, 5, 6 until 100. I'm saying, okay, look, X, as it takes on these values, I need a value of 2 times of X in my list numbers. And this is really pretty cool. We will look at the range function, extremely important when we look at the for loop. But let's just see this in action right now. Let's say I'll stop this. Let's try to understand this comprehensions a little bit. So I say, let's say numbers is equal to, let's say, 2 times X for X in range, let's say 1 to 101. Now, if I were to do this and I look at numbers, notice numbers is a list going from 2, 4, 6, 8 all the way to 200. In other words, I have got the first 100. If I look at, let's say, length of numbers, I've got the first 100, let's say, even numbers. Let's say I do the same thing, but this time around I call numbers as, say, 3 times X. Well, it's exactly similar. So I just say I've got numbers, which is a list of first 100 multiples of 300 starting at 1. So 3 times 1, 3 times 2, 3 times 3, all the way until 3 times 100. Now you can see this is going to get quite interesting. We can get multiples of any number. We can, let's say, look at squaring these numbers. So if I were to say, okay, why don't you square this for me, exponentiation, I will get a list which is, if I look at numbers now, I will have a list which are perfect squares of, say, square of 1, square of 2, square of 3, all the way until square of 100. Now this is again quite interesting, very concise, how this is happening. We can look at one more example. Let's say I want to get all odd numbers starting from 1. So, well, I could do X times 2 and say minus 1, or say 2 times X minus 1. Remember, in this case, the priority is higher for the multiplication. So multiplication will happen first, which means basically I'll create the even number and subtract 1 from there. So if I look at numbers over here, it's basically first, let's say, 200. First 100 odd numbers. So we can basically, instead of running this over, let's say, n, which is randomly picked up from 1 to 100, what I can do is I can just go and say, look, numbers is For example, let's take the case of even numbers. So I say, okay, numbers is, let's say, 2 times x for x in range, you know, range, let's say 1 to 101. Now, like I said, this range, is gives you a sequence of numbers, extremely powerful, as we'll see a little bit later. But this will give us a list of all even numbers. Now, all we have to do is to say, okay, look, n is equal to numbers, so sorry, random dot choice numbers. And what this will do is that it will pick up any one number randomly from this list. Now we must be a little bit clear. So I say I've picked up, let's say I've selected, a number, say from the first 100, let's say, multiples of 2, or say even numbers, say I just say multiples of 2. Can you guess? Now, with this done, pretty much my n is being selected. And in fact, we can see this happening right now. Let's say I'll just control C here, but let's look at n. Notice n is 154. N will always be an even number because, that's what I'm doing. I'm picking up n, let's say from, this list as a multiple of 2. Now, if I wanted, let's say multiple of 3, let's say multiple of 5. So I can say, okay, look, I'm going to get the first 100 multiples of 5 by that statement. It's all inside that list. So I say control C. Let's look at the list numbers. It's 5, 10, 15 until 500. And if I look at n, n has been chosen also from this list. Now, having done this, now of course, if I pick up 5, then I must change this to, let's say, multiples of 5. In fact, we can make it a variable there. So, everything can be put through a variable and it becomes very flexible. So I can have a variable, let's say, and, I can print the statement also in a very flexible manner. Let me just make that, to generate this list which are in a pattern, it's okay. But if you want to do things like, let's say, Fibonacci numbers or prime numbers, etc., then more work will be required. In fact, we look at this as well. It's itself quite interesting. But now, basically, we need to do a little bit more check when the player guesses. Remember, the way our code works is that while not done, which is to say that user is still not being able to, guess the number, we keep asking, please guess a number, and we keep telling the player, okay, look, if your number is smaller than the given number, or let's say larger than the given number, but now an additional check comes in. We must, also check whether this number that the user is even a valid number. Because remember, we are tell me a number which is a multiple of 5. And if I go and tell, let's say 234, that's not a multiple of 5. I must immediately tell my player. And since we are not looking at just multiples, we could be looking at, let's say, prime numbers. We could be looking at, let's say, Fibonacci numbers. We could be looking at some very special numbers, as we'll see later. Instead of doing a mathematical calculation here, I just say, okay, let me just check if this is inside the list numbers. Now, in is basically telling if the list numbers contains this guess, then it's fine. I can go and do exactly what I was doing. Else, I'll tell my player, well, look, that was not a valid guess. Perhaps you should guess again. And, again, mark here the indentation because I'm putting if inside the while loop. So if is indented, but the entire code that was previously, let's say like this, intentionally I've shown it this way. It gets indented one level inside. Actually, this. Now, so we come in here, let's see how I modify this code. So I just go and tell my player, okay, look, I'll have to check one more place here. So I say, if, let's say, player guesses a number, if guess in, say, numbers, remember numbers is a list. I do all of this. So I select, let's say, all of this here and I give a tab. So that indents it nicely. However, if that is not the case, which is to say in else, I just go and tell my player, look, your, so print, let's say, um, your guess was not a valid number, let's say. I mean, all it means is that it was not part of that list and hence it was not valid. So let's just play this and see how it goes. So let's say I'm looking at multiples of 5. Now, clearly I've picked up something that's a multiple of 5. Let's try. And we are dealing with first 100 multiples of 5. So let's say I try 100. My number is larger than that. I try, let's say 350. That's okay. It says larger than that. That's time I say 403. Now, clearly that is not a valid guess because this is not a multiple of 5. So I say this is not a valid guess. Your guess was not a valid number. Well, actually, your guess, I think a better message is to say your guess is not valid instead of saying not. It's a valid number, but not a valid guess. So I say, okay, let me be more careful. I say maybe I'll try 410. Number is smaller than that, so it's between 350 and 410. So I try 380. Smaller than that, so I 370, say 375, and it indeed was 375. Now notice everything remained exactly the same. The only thing that changed really was that instead of picking up a number in this range 1 to 100, now I'm picking up a number from this list, and the game has become that much more interesting because this list can be made very, very interesting as we see in a later video. However, when it comes to the player, choosing a number and, computer guessing, again, player must choose a valid number. Now, all really that has to happen is that player has to guess, as rather the computer has to guess from this list numbers, which means that instead of just guessing, we are going to use guess as an index and index into this list. And really, this is very similar to what happens when we chose, let's say, alphabets to play this game. We just have to make sure that our guess remains confined to range 0 to say length of numbers minus 1, because we do not want indexing errors to happen, right? So basically this means item guess of numbers. We write it concisely numbers guess. We have seen this before, and we will encounter this a lot as we go forward as well. So I come in here, I look at my code, my code for the second part is basically saying that, okay, look, now is your chance. You select a number, let's say, select a number between, it's a bit number. I just make it multiple of, say, 5. Let's say, select number from the first 100 multiples of 5. So if I did this and I say click when ready, so once the user is ready, it starts clicking. So I go with 0. But remember, I am not going to convert this as it is. I'm not going to take guess as it is. In fact, I'm going to say look at numbers, let's say guess, because that is the guess that the player is and the computer is making. Now I just have to make sure that my, so that's the guess that. Now everything else remains exactly the same. I just have to add this condition, in fact. So I just say that, okay, if let's say guess becomes more than, let's say, length of numbers, numbers minus 1, then I set my guess to, let's say, length of, say, numbers minus 1. And if, let's say, guess becomes less than 0, then I just go and set my guess to, say, 0. Now this is really setting the boundaries. It's exactly same as what we were doing earlier. We were limiting the boundaries to 0 to, say, 1 and 100, but now we are indexing into a list, and hence we just have to, take care of this. And of course my guess step is 10. That's fine. So it's going to make 10 indices. There'll be a lot of jumps here. Let's just see this. So what I will do, again, to sort of speed this whole thing up, I will set the done to true over here so that I directly go to the second part of the code. And now when I run this code, right, it's interesting because when I run this code, for example, it says, well, it's first 5 multiples of, first 100 multiples of, say, 5. I have chosen a number. Let's say my number is 255. Let's see. So I click enter. Is it 5? Well, no, it's not 5. It's larger than that. Notice it asked me 10 multiples later, which is 55, right? In fact, my number is 255. So I will just keep going. I'll say, well, larger, 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 larger. It just so happens that so let's say my number was, it just picks it up. Let's say my number is 245. So I say, well, it is smaller. So I say smaller. It tries 210. I said larger. Now notice the convergence has started to happen, right? So I say smaller. It tries 215. I said larger. It said 245. Yes, indeed, it was 245. Now notice the whole thing is just working exactly the way we would think. Let's just take one more example. Let's say we change this game right now, and I say I want to get, let's say, the first 100 perfect squares. Right now this is obviously hard for us to immediately remember. So I say I have selected, let's say, from the first 100 perfect squares, right? So which means these are like, and can you guess, right? Again, I'm going to come directly to the second part of this. So I must actually, maybe we can play both the parts. So again, let's say I set this to false. So computer is going to pick up, say, perfect squares, and so am I later on. So I just go and say, now your chance. I have selected, you select a number, you select a, say, perfect square, right? Let's say, and assume that the range and all is understood. You can make it more cleaner. And everything else will start to keep on working the way it was. So let's just go with this. Let's say, so I says guess the number. I picked up perfect square. Now this is hard because I have to be very careful. Let's say I try with 4. My number is larger than that. Let me try, let's say, 20 square, which is, say, 400. My number is smaller than that. Now let me try, let's say, smaller than that. So it's between 2 square and 20 square. Let's say 10 square, that is 100. Larger than that, let's try 15 squares, or 225. Smaller than that. Now let's try making, let's say, so it's between 10 square and 15 square. Let's say I made a mistake. I want to try 11 square, but I tried this. It tells me your guess was not valid because 121 will be seen as a valid number. Let's try 144. Larger than that, 169. I got it correct because my number was happened to be 13 square. Now this gets quite complicated, in a way, because we have to think of these perfect squares now. So now my chance, let's say I choose a number which is say 25 squares, so 625. Let's see what happens, right? So it asks me, is it 1? Because it starts with 1, remember? I said, no, well, it's larger than that. It says it's 121. No. Is it 441? It's 21 square. No. I said larger than that. It's a 961. No, no, it's too much. So I say come back, come smaller. Is it 484? I said larger than that. Remember my number 625. Is it 900? I said smaller than that. 529, larger than that. 841, smaller than that. 576, larger than that. 784, smaller than that. 625, yes, indeed, that is my number. It took me 11 attempts to get here, but pretty cool. I hope you found this interesting. In general, if you think this way of learning by building fun activities, thinking about how we can enhance them, building on top of them helps you to understand concepts better. Look at our website because we have many such activities. Take care. Thank you so much. Bye bye.